Good morning, Ola. How are you?
Fine. I joined the meeting. Maybe I could learn from others' question. That's why I joined the meeting this
Oh,
morning.
okay. No, not a problem. Let me see now. I think at this moment you are the only one, as far as I can tell. So somebody did ask me to have a consult today. That's why I organized it. So I don't know if they're going to
So let me just hang around and
join. Yeah.
Thank you.
Yeah, no worries.
Going?
All right. Thanks. How are you?
I'm pretty good. I just have a couple of questions about the project
Yes.
two. My first question is about the FEV, question 2C, part 3. Oh no, sorry, 2D, part 3.
I'll pull that up.
Thank you.
Okay.
So my question is, in my FEV diagrams, I have that that what happens to Y, the large cap, is more important than what happens to the variable for X, for the medium cap and the small cap indexes.
You said 2B.
Sorry, 2D.
D, okay. Okay, so we're looking at the, and then you're talking about the forecaster variance decompositions or IRFs.
Yeah. No, the forecast error variance.
Okay.
Decomposition. Yeah, so I was wondering, is that okay? Like,
well, you can ask. I'll tell you if I'm able
theoretically,
to.
Pardon?
So you can ask and I'll tell you if I'm able to answer questions about the project.
Okay, so my question pretty much is that I suppose, is it okay, is it the case that a different variable will have a big impact on, like, let's say variable A, is it ever the case that variable B will have a bigger impact than variable A itself?
On what? On its
on
own,
variable A.
Forecast error variance.
Yeah.
So I guess you're associating the shocks with a particular variable, which is sensible for a Koleski decomposition, but also you think that in general, it's not about variables affecting other variables. It's about some independent shocks in the system driving the fluctuations over time in different variables, right? So you could you think of it more generally, like there could be in an economic system, but here we have finance, let's say, not be directly related to the project, something like economic system. You've got things like GDP, unemployment, inflation, and interest rates, let's say, fluctuating, right? And you want to understand what's driving those fluctuations. I think a good example to always kind of fall back on is the question of what's driving things like business cycles. What are the different shocks in the economy? So they could think of lots of shocks. There could be like shocks to the productivity, right? Technology shocks, or policy shocks like monetary policy shocks, or fiscal policy shocks, such as government spending or taxes. Lots of different things that could be, people always argue about are maybe creating these business cycles and fluctuations, or maybe are not having any effects, or maybe only having long-term effects. So it's a mapping from, like, a forecast error variance decomposition is a mapping from these different sources of shocks basically to the system, and mapping those to fluctuations in some observed variables. Making sense?
Yeah.
So when I look at, let's say, a variable such as inflation, and I say, okay, I know inflation is fluctuating over time, and I want to ask the question, what's driving those fluctuations? So the idea is that if there were no shocks, inflation would be perfectly predictable, right? Because there'd be no future errors, no future shocks hitting the system. And as long as inflation was stationary, we'd know exactly what path it would take. Well, it would just be the mean, correct?
Mm-hmm.
Does that make sense? What's causing it to
Yeah,
deviate? Yeah. Or if it's non-stationary, it would be that trend, basically.
Mm-hmm.
So what's causing it to deviate from the trend, or what's causing it to deviate from that unconditional mean, are some shocks that keep hitting the system, and they're driving like the variable, let's say inflation, up and down, but then it's always reverting back to the mean, and then new shocks hit it, and again it, you know, goes either up or down, and then with something pushing on it back towards the mean. That's sort of how we envision the system moving around. And same thing with finance. And so the question is, you know, the idea behind why do we call it forecast error variance? Well, again, if we're trying to forecast inflation or one of these variables, the reason we cannot forecast it perfectly is because we know there are going to be shocks that are going to hit it in the future that are going to muck up our, you know, perfect forecast of unconditional mean. And so the question is, and that's basically, you know, you can see the link to the question, what's driving the fluctuations versus what's causing our, you know, the uncertainty in mucking up our ability to forecast this variable. So, and you think of it in terms of all these shocks and say, okay, then which shocks are the more substantial ones, like in the short run, in the long run, and so on. So, you know, which of the shocks are really interfering with our ability to forecast, let's say, inflation in the short run. And so we kind of break it up, like the most significant source of uncertainty or fluctuations may be the monetary policy shock. And the second most significant may be, you know, I don't know, some other technology shock.
Yeah.
You understand what I'm saying? And then same thing like in the medium term. Okay, in the short run, maybe the most significant source of fluctuation is the monetary policy shock, but then all those fluctuations or the effect of monetary policy gets worked out like within a year, but there's still a lot of fluctuation in inflation, let's say in 5 years. What's causing that? Maybe it's the technology shock. So the relative importance of the shocks can change also depending on what horizon we're talking about. And so, yeah, if you go back and think about, okay, we're doing a Koletsky decomposition. So all we're doing is we're kind of associating with, instead of calling it a monetary policy shock, fiscal policy shock, technology shock, or something else, we're saying it's some sort of a shock that only pertains to this variable, and then there's another shock that only pertains to this variable initially, right? But only on impact. So there's a shock that only affects whatever's ordered first on impact. But then that shock will affect all other variables going forward because they interact. And so in that sense, there's no difference. Like when we say like when you say it's a shock to one of the variables from a Koletsky point of view, all we're really saying there is it's a shock that will affect only the first variable within, you know, one period. But then going forward, it can affect all the variables that normally would affect all the variables because they interact. So in that sense, yeah, in the very short term, you know, immediately whatever's ordered first would only be affected by its own shock. But then as time progresses, you know, that shock could end up being more impactful on other variables, right? That's the whole point of the analysis.
Okay.
Yeah. Make sense?
Makes sense. All right. Yes, thank you very much. That was very helpful. I appreciate it. And then my next question is for the same graph. See, there's a confidence interval surrounding the line. In mine for the project, there doesn't, either the confidence interval is so small that I can't see it.
Okay.
Is that possible for, is that possible?
That the confidence interval is so small you can't, it's not distinguishable. Yeah, it's, of course it's possible. Yeah. It depends on how small it is.
Okay, so that wouldn't necessarily indicate that I've done something wrong?
Not necessarily. I'm not saying you didn't. But I mean, yeah, if it's just something very, very you know, if you have a very small confidence interval, it's just saying that your estimates are very precise. So, I mean, probably worth investigating. If it's something very, you know, seems out of the ordinary, then probably worth looking into. Like, you know.
And this is the estimate of
Yeah.
the future variation. See, that's
Right. So you have to sort of think about what
is that right?
how to interpret it. I don't know if it's right.
Oh, sorry. No, I wasn't asking if not having
Oh.
a confidence interval is right. I'm asking that that I have the correct understanding that it's a confidence interval around the forecast area variance.
Yes, because again,
right?
the forecast error variance
line.
is also an estimate, right?
Right.
What's the source of uncertainty there? The source of uncertainty is not in the actual forecasting because we're fixing the shocks, but the source of uncertainty is in what? It's in the parameter estimate.
Okay.
Yeah.
Okay. All right. I do have a few other questions, but I'll just mute just so I can gather them all. I wasn't sure whether this consult was going. I didn't quite come prepared, but thank you very much for answering those.
Yeah, you can just email me the questions when you're ready. So fine.
Okay. All right. Okay.
Yeah.
Thanks, Eric.
No worries.
Hi. In our project, question 2A, it asked me to name 2 alternative criteria which can be used to select P. Do we need to introduce how to use it, or just name it?
To name 2 alternative criteria in question 2A.
Yeah. So we just need to put 2 names, or we need to introduce how to use them.
I mean, you can. It doesn't have to be very long explanation. Yep. It may be very, very brief. You don't have to put a big one.
Okay.
Yeah. Like
within
a sentence, let's say.
Okay, but
it's not looking for a big, detailed explanation of the criteria. So something closer to just naming them. Although, I mean, you have to. I can't say just list 2 things. I mean, because if you list 2 things and the marker doesn't understand what you've listed, then it'll probably be a bit helpful to, right? Like be more precise, but yeah, not like a long explanations of what they are. Just as long if you think it's clear enough, then list the 2 criteria and that's it.
Okay. But if I put a likelihood, if I put a likelihood ratio test, we haven't started.
I can't tell you. I can't tell you if it's okay to put an answer, right? Just you have to answer the question, and you know, just whatever you feel is needed for the person marking to understand what you listed, then that's enough. So you don't have to explain in detail.
Okay.
If you think putting LR test is self-explanatory, then just leave it. Or if you think you need like another qualification, then it's okay to add a qualification. So I don't have a specific guideline here.
Okay.
Just don't make it too long.
Okay. Thanks. And I have some questions about the lecture 7 to 9.
Which lecture?
7 to 9.
Lecture 7.
To 9.
Oh, all of them, all 3 of them. 7, 8, and 9, or which, I didn't understand.
7 to 9. So first one, 7.
Yeah. Okay. You can a particular slide or?
Yes. 12, page 12.
Okay. Lecture 7. Okay. Okay, slide 12.
Page 12.
Yeah. Here.
Oh yeah, is this NRE square? Our tutor says it's NRE square.
Sorry?
That's one. And the circle, which is circled. Is this NRE square?
The R squared, yeah, from the regression.
Is RE square or NRE square?
Oh yeah, with the N, yeah.
Yeah. Okay.
Yeah, sorry, it's missing the number of observations.
And 13, page 13.
Yeah.
Okay, but beta 1 is beta J, right? Yeah, I think so.
Probably. Beta J, yeah, instead of beta 1, yeah. A little typo.
On page 10, what does E epsilon TVT minus S equals to 0 mean? What's the particular meanings of this?
What does it mean? Well, what does it mean? If they're both mean 0,
they are uncorrelated.
Yeah, what does it mean when the expectation of their product is 0? You tell me.
Are uncorrelated. So why we need it? So why we need this constraint?
Why do we need them to be uncorrelated? Well, I mean, we need that for all the other derivations, right? So if they're correlated, then the problem becomes very different.
Lecture 8.
We'll go to lecture 8?
Yeah.
Okay.
Yes. Page 17.
Yeah, 17.
Yeah, page 17.
Okay, this one.
Yeah. Is this conditional variance of epsilon t? Because I think it's increasing function of ht, and ht is e epsilon t square, and I think it's variance of epsilon t.
Yeah, it's an increasing function of the
ht,
which is the conditional variance of epsilon t. So yeah, not epsilon.
Yeah, so
not epsilon t.
Yeah. And on page, on page 9.
9.
Yeah.
Yeah.
I'm not very clear why GVT minus y is equal to lambda v.
Why? G
Why?
VT minus 1 is equal.
Yeah,
Why we get that
yeah.
equation?
Yeah.
Well, you just have to, I mean, work out some algebra. You can try it, and you send me the derivations.
If this equation holds, I think so. Alpha 1 expectation of absolute value of bt minus 1 is equal to alpha 0 beta 1. So like this. This is my theorem. I think maybe it doesn't matter. So it doesn't matter.
Which one?
This equation. So we don't need to know how it.
No, it's not very important. I mean, if you can, you can try to derive it for fun. I mean, and if you want, I can have a look at the derivations. But yeah, it's not particularly important. I mean, the whole point is just that you can convert it to a model that looks like an autoregressive model, and then you can derive the forecast from it in this sort of fairly straightforward way. You don't really need to. I mean, it's based on basically the properties of a half normal distribution. So you just rearrange the terms a bit in a way that the expectation of this G term is 0. That's kind of the point.
So lecture 9.
Lecture 9.
Yeah.
Not switching again. Lecture 9. Here we are.
Page 9.
Page 9.
Yeah.
Okay.
The last one is this EZT minus X. That?
Yeah. So
Not Y, right? ZT.
Yes, ZT. They're also uncorrelated.
Okay.
Oh, sorry. No, so the second, yeah, the one on the right side, it should be EZT minus S.
Oh, okay. And 11, page 11.
Yes. This one.
It's a number of variables in. Is this endogenous variables or in V?
Well, in a VAR, a pure VAR, we always have all the variables are endogenous.
All the variables
in a pure VAR. So we'll distinguish that from a VAR X, where we have endogenous variables, but also exogenous.
Okay. Okay. Yeah, I see. Okay, that's all.
Yeah.
Thank you. And when will this consultation be uploaded online?
Sorry. Consultation.
Yeah.
The recording.
Yes.
Yeah. I'm recording it. I hope so.
Yeah, but when will it be uploaded online?
Yeah. If I record it, of course.
So I mean, when will it be uploaded online so we can?
This consultation.
See. Yeah.
Maybe today.
Okay. Thank you.
Yeah.
Thank you very much.
Yeah, no worries.
See you.
Yep.
Hi, Eric. I have my other questions gathered up now.
Yep, great.
Okay. So Please try and withhold judgment, but I have a question about one-sided tests. So
Okay.
this is in relation to the T-arch and the Garch M. Well, any of those, well, yeah, those two in particular. So with the one-sided tests,
Yeah.
my understanding was that the null hypothesis should be equal or, well, so hang on, let's say with the T-arch test, where am I? 1E. With the T-arch test, my understanding was that the null would be equal to or less than 0, and the alternative.
No. So in any hypothesis test, no matter what it is, the null hypothesis is always equal, right? Because yeah,
okay.
it's all. So when we say one-sided or two-sided, it's always about the alternative, because we always need the null to be equal, because it's assuming the null hypothesis, we derive a test statistic. So yeah, just always think about it that way. Remember, how we compute the test statistic is to assume the null hypothesis is true, so that we eliminate all the unknown coefficients by replacing them with some numbers, and then we're able to derive a test statistic. If we were to assume like an interval for a null hypothesis, then our test statistic would involve an interval, so we would not be able to actually compute it. Yeah,
Right.
yeah, just go back to the basics. I know sometimes we get caught up with all these terms and things.
What I did, I thought, because I had originally had it as 0, but then when I was trying to look, I thought that I had seen on lots of different places that the null was. So
no, that wouldn't be correct. I mean, there may be places where that appears. I don't know, but it's like from a pure mathematical point of view, it cannot be correct. We need a null hypothesis to be a fixed point.
Right. Okay. Okay. So then, for the critical values, because it is one-sided, should we be using like for 5% significance? Should we be using like the one-sided critical values?
Yeah, if it's a one-sided test. Yeah.
For a one-sided test. Okay. Just because I think in the tutorials and those types of things, the values were so far from the critical values that didn't really come up. You know, like the test statistic was.
Well, you have to.
Whatever, 20.
I know, exactly. So the point is, most of the time it won't matter, right? Because you'll either have a test statistic that's really, really large on the right side of the fence, and it doesn't matter what the distinction just isn't practically relevant. Or you'll have a test statistic that's so low that, again, it doesn't matter. Distinction is not relevant. There'll be only a few cases where it's going to fall right between the one-tailed critical value and the two-tailed critical value, right?
Yeah.
And that's the only time you really have to, kind of worry about which of the tests are you conducting.
Okay. All right. That's that one. And then I just have a question about it relates to question 1B, but is fairly general, and that is when we tested in the tutorial for the existence of arch-Garch effects.
Yeah.
We tested arch for the Q value being 1, 2, 3, and 4 in the tutorial. But why did we test Q equals 1? Like, why did we test 4 different times? Why didn't we just test like Q equals 1, for instance? Did we test Q equals 1, 2, 3, 4 because in our, I think, squared residuals, there was like a bar coming out? I tried to ask this of a few different tutors throughout the week, but I haven't been able to get
which
an
tutorial?
answer. Sorry, this would be the arch-Garch. So tutorial 7?
8 maybe?
8. Sorry, hang on, I can tell you. Tutorial 7. Tutorial 7.
Tutorial 7.
Yeah.
And we looked at the. Let's see if I can find.
Testing for arch effects. Oh, so it's part E on tutorial 7, I think.
test if the errors in your chosen model contain arch or Garch effects. Okay.
Yes.
Again, we did the LM test.
Yeah. But
Yeah.
why do we do it for Q equals 1, 2, 3, and 4? Like, why specifically those numbers?
Just to practice.
As in,
different. I
how
mean, you're trying out different models, right?
yeah.
So it's like, remember when you do the LM test, the Bruch-Pagan test, it's you're taking a sort of a general approach, doing the errors, and your null hypothesis is that they're homoscedastic, and your alternative hypothesis is it's some form of an arch model. So you have to, it's the same thing as like when you're picking the alternative to be one-tailed or two-tailed, you have to make a choice. What are you testing? Because that'll affect the critical value that you're comparing to. So here we just have to, choose an alternative to the homoscedasticity assumption or hypothesis. So if it's not going to be homoscedastic, it must be an arch model under this setup. So what type of arch model? We have to pick the number of lags in the sum squared residuals in the arch model. So, I mean, you cannot say that if I pick arch 4, then it's already nests an arch 1 in this sort of context, right? Because if I pick an arch 4, the implication is that an arch 4 fits better than an arch 1. And it's
Right.
so they're not exactly equivalent. Otherwise, we would always be choosing like an arch 100.
So for this in general, then, do we just pick a variety of values of Q? Because we're only testing for, we're not testing for the exact model. We're just testing that the.
No, we're not testing. We're just testing homoscedasticity, right?
So is then the answer, if you test it on a variety of Q values, and in all cases you reject the null hypothesis, then you can say, yeah, we can, there is significant evidence to reject the null hypothesis of no arch effects, but it doesn't matter so much.
Like, it's all context specific, right? So if you take an LM test as your way of detecting heteroscedasticity, and you say, I'm able to reject it for an arch 1 in favor of an arch 1, and I'm able to reject it in favor of an arch 2, but maybe not in favor of an arch 3 or an arch 4. What's the conclusion? Can you, in this case, you did not reject in all 4 cases, but you rejected in 2 of the cases. So your conclusion is still that you have rejected homoscedasticity, right?
Yes.
Some arch model.
Yeah.
If you reject for all 4, then you could take that as anything is better than homoscedasticity. Whereas in the example I gave you, conclusion is something like, well, there are some arch models that are definitely preferred to homoscedasticity, but not all arch models are clearly preferred to homoscedasticity.
Okay.
Right. So it's all about, again, the whole trick here is, and I know it's tricky, and it takes a few years probably to kind of get the hang of things, is that we don't have very precise, unfortunately, methods and procedures for detecting things and saying, right, it's all like we've got these semi-scientific kind of tools, and we have to learn how to apply them correctly in different contexts and how to interpret them. So it's a bit like that, yeah.
Okay, all right. Yeah.
Does that answer your question?
Yeah, it did. Yeah, it did. Thank you.
Okay.
And then for the, can you just go over when kind of around that same, when we're selecting the ARMA models and then we're looking at, like the mean part before we go on to look at the variance part.
Yeah.
When we're doing that, we have to look at the residuals in terms of white noise. Can you just go over when we look at the residuals and when we look at the squared residuals? I'm a bit confused about when we should just use the.
So again, we're looking at ARMA models, and similar, we're looking for a specification in terms of the lags, right? We've got 2 options. One is to choose in sort of a baseline case. One is to choose the number of lags of the variable itself, and the other is to choose the number of lags of the residuals.
Mhm.
And the idea is that if under a correct specification, presumably what's left over is going to be a white noise residual, right?
Mhm.
So that's just on the levels of residuals. When we're looking at correlations, we may choose that correctly, let's say, or we already know for some reason that what specification is. And then the second question is that we look at is the autocorrelations and the squared residuals. So a residual series could be uncorrelated because we've chosen very well the number of lags in the ARMA model, but the squared residuals could be correlated. And when the squared residuals are correlated, what that's telling us is that the model, the errors are not homoscedastic, that there's some time variation in the variance and some correlation on the second moment order of the residuals. So that's related to the variance of the process, right? Just think squared residuals are associated with the variance. If squared residuals are correlated, then there's something about the variance of the process that's not homoscedastic. So this is the
I
difference.
get it.
Yeah.
Yeah. Okay. All right. That makes all the sense. Thank you very much.
Great.
That
Sure.
was great. That was really good. Thank you.
Absolutely. I'm glad to hear it.
My last is it hopefully is pretty quick, but we're now moving back into kind of question 1A and talking about the stationarity of a variable. I was just wondering, I thought the stationarity of the variable, like we looked at the mean, and that was obviously the first weeks of the course. Now we're looking at it in terms of the volatility. So in the tutorials, even though when we're looking at the time plot and we're looking at everything, the answer keeps being that the variable is stationary, but it's not, because then we're going on to fit a volatility model. So I wasn't sure because the question, the answer always seems to be in the
no, okay. So when we're looking at the things like, you mean with the trends and
tutorials.
Yeah, that's all related to just the conditional mean part. When we're talking about the,
I was just wondering, could you?
Sorry. No, I can't hear. What happened?
Can you hear me?
No, very poorly.
Is that better?
Yes.
Sorry.
Yeah, I can hear you now.
Okay. So, sorry. Are you able to start that explanation again? I think I lost you partway through.
So if I understood correctly, you're saying we have a whole like part about determining the, like with the Dickey-Fuller test and stuff, about the stationarity in terms of not having stochastic trends in unit roots. Did I understand correctly?
Yeah.
Yeah. So again, all that part is related to just the conditional mean of the model.
Mm-hmm.
That's not saying anything about the variance or covariances. Whereas stationarity, and that's why I try to avoid the term associating stationarity all the time with no unit roots, or which, the term like trend stationary is a bit, I think, confusing, because when we say trend stationary, the underlying assumption is that the model is homoscedastic. Whereas, yeah, we can have a model with a basically very simple conditional mean, just being constant or even zero, but the model is not stationary because the variance is not time invariant. So stationarity requires all those moments to be fixed in time.
Yeah. So in the tutorials then, when the answer is yes, it is stationary, is that because the question is only referring to
homoscedastic models?
Okay. So I know you don't want to speak specifically about the project, but question 1A, the only thing it has asked us to look at, like it asked us to do the ADF test and then conclude, do you think RYT is stationary? For that, are you only referring to, because we haven't started talking about?
Yeah, so you should just explain that, the way we're explaining it, right? Assuming the volatility is constant, or assuming the model is homoscedastic, and then you can say about the stationary part, right? As long as you explain it correctly.
Okay.
That should be
All
fine.
right. Okay. All right. Okay. Thank you very much for your help, Eric. That is all my
No,
questions.
not a problem at all.
Thanks. Bye.
Yep. Okay. So I'm gonna have to run now. I've got another meeting. But you guys have other questions, just email them through. I'll be happy to have a look throughout the week. Thanks again for joining.